Going on to the last chapter we'll be doing in this course, and the first section of Chapter 5, Exponents and Scientific Notation. Now we'll be giving you some background information as we go on, and that's of course what the text does. And we're going to take a look at 5 to the third power. Well, this is a shorthand way of writing your base, which is 5, 3 times. And then we use the superscript 3, which indicates that you're doing that 3 times. So the 3 is the exponent, and the 5 is the base. Now when we have something like y to the 6th, again, this means that you're going to take this y as a factor 6 times. So y is the base, and the superscript 6 is your exponent. And this is what we call an exponential form of the word exponent, exponential expression. Now, what they'll be bringing you into is when you see something like this, x to the 2nd times x to the 3rd, and if you were to write it out, it would look like this. What would that equal? Well, you have 5 x's, so that's x to the 5th. So from this, we get the rule, if we're just multiplying variables with exponents, and it's the same variable, we then just add the exponents. That's the basic rule. And we see that in this little blue strip where they give us these summations. Alright, let's do example 1. They lay it out quite nicely. We're just going to add the exponents. Our base is 2 to the 7th. X to the 10th. Now keep in mind, when there isn't an exponent showing, it has the exponent of 1. So y to the 7th. Now in example 2, they've complicated it just a tad. We now have added numbers. Well, in this case, we're going to multiply the numbers and get 3 times 5 is 15, and then add the exponents on our variables, x to the 7th. And we need to be careful of the signs. So there's a negative times a positive, which will give you a negative. And when you multiply that, it's going to be a 9.6. X, we have 3 and 1, that'll be 4. 2 and 10, that will be 12. Now in objective 2, we're going to evaluate expressions raised to the 0 power. Well, examples of this would be a to the 0 power, 5 to the 0 power, and by definition, and I'll show you this a little later, what is any base to the 0 power? And the answer is it's a 1. Anything, any base to the 0 power is 1. Now, of course, the exception is 0 to the 0 power is not 1. In fact, I don't know if we define that or not. Okay, so here, if something is to the 0 power, adding that to anything, it's just the thing. So in a sense, a to the 0 is a 1, and then you just have what is left. And here is what we've just illustrated. If a does not equal 0, which we're saying it doesn't, then anything, any base to the 0 power is 1. Now in example 3a, 7 to the 0 power is 1. Now in letter B we have a negative 7 to the 0 power. Now this is where it gets a little tricky, because what is our base here? Is our base negative 7? Or is our base just the 7? Well, when it's like this, it is just the 7. So 7 to the 0 power is 1, but then we have to apply the negative. So this is negative 1. Now, as we look at letter C, what is our base? Well, because of the parentheses, it's all of this. So all of C, since it's to the 0 power, is 1. Now for letter D, again, what is our base? Is it 2x or just the x? Keeping this in mind. It's just the x. So x to the 0 power is 1. We now have 2 times 1, which is 2. And they're showing and illustrating that. And these are very similar. So let's just do this. This is going to be 1. This, negative 1. This, 1. Now here's our 1 times 3. So this would be 3. Our next objective is using the quotient rule, where we have something like this. X to the 9th divided by x to the 2nd. Well, if you were to string these out like so, you would get 9 x's and 2 x's. And we say anything divided by itself is 1. So these are a couple of 1's. So what do you have left? X to the 7th. Now, if we were going to develop a rule for this, what might you do? Well, as I'd like to describe it, is you take your exponent from the denominator, which is a 2, and as it crosses the division bar, the sign of the exponent changes. Here it was a positive, it's going up, it's changing to a negative. And we then get 9 minus 2, x to the 7th. Good little technique here. And the general rule for this is that as an exponent crosses this division bar, the sign of the exponent changes. And we'll use that again. In fact, let's do something here. We had said x to the 3rd divided by x to the 3rd. Now we're going to use this rule. We're going to bring this 3 up and get x to the 3rd minus 3 What is 3 minus 3? 0. And what did we say anything to the 0 power was? 1. Now, let's look at this originally here. We had said that anything, as long as it wasn't 0, divided by itself is 1. And we have just proved, using the quotient rule, that if we did this, we'd get x to the 0 power, and that equals 1. So this is the proof of what we did in objective 2. So the rule is, when you take an exponent and cross the division bar, the sign of the exponent changes, and in this case you're just doing the subtraction. Okay, let's work on example 4. So we can do it mentally. 4 from 7, x to the 3rd. 2 from 8, 5 to the 6th. Now, when you have numbers, you have to do the numbers too. So 4 goes into 20. Here we're actually going to do division 5 times. 5 taken away from 6 is x to the 1st, and we don't write the 1. Now for this one, we can take a 2 out of each one, so we get a 6/7 there. Here we're going to get a y. 8 from 10 is 2, and this becomes z to the 0, which is just 1, so we don't write it. And that's what we get. Now, another way to write it is this way as well. These two are equivalent. Now, in objective 4, we're going to take a look at negative powers. So let's take a look at that. Suppose we had x to the 3rd over x to the 5th now. Well, if we did what we said, we're going to take our 5, subtract it from the 3. This is a 5 here. And we now get in the numerator x to the negative 2. All right, let's do this a different way. X to the 3rd over x to the 5th. Now remember, there is a 1 in front of that x that we don't usually write. But I'm going to write it here because now I'm going to take this 3 and bring it down across the division bar. It changes its sign, and I now get 1 over, that's a 3 here, x to the 2nd. All right. So we did it this way and got x to the negative 2. We did it this way and we got 1 over x to the 2nd. So this must mean that x to the negative 2 is equivalent to x to the 2nd. So often when we're working with exponents, they will tell us they do not want negative exponents. So this is a negative exponent. How do I make it not a negative exponent? Well, again, everything is over 1. You just bring it down to the denominator. Or another way to look at it is just take the reciprocal of it, and it's this. But the sign changes, remember. Going across that division bar, the sign changes. So here is the rule. So when something, and again this is over 1, in the numerator is negative exponent, just bring it down to the denominator and the sign changes. Now remember, you have to put something up in the numerator to indicate then this is a denominator. Because if you don't have the 1 in the numerator, you can't tell that this is a denominator. Okay, let's go and do some examples now. Now, again, in our textbook, all of the solution is down below, but we want to work these out. And we want to simplify as well whenever we can. So, 5 to the negative 2 would equal 1 over 5 to the second, just bringing that down to the denominator, and that's 1/25. Now, taking a negative 4 down to the denominator, that's going to be 1 over negative 4 to the positive 4th power now. And this is going to be a 1. And then negative 4 times itself 4 times is a positive 256. Now in this next one we get 2x to the 3rd. And once again we must, that's a negative 3, x to the negative 3. That the 2 will remain in the denominator, in the numerator, and only the base x will go down to our denominator. So remember, this is the base. The base is what is to the immediate left of an exponent. Now, unless it were in parentheses, then it would be something else. I will do a few more. This is letter D. So all we're going to do here is put a 1 in the numerator and bring this down. Now because of the parentheses, all of this is the base. And then here we're going to have a 1 left in the numerator. We're going to bring our 5 down, subtract it. We get m to the 10th. Here we're going to have a 1 left in the numerator. I didn't write that very well. And the denominator now will be 3 to the 3rd as I subtract 3 there. And this is 1/27. And again, all of these are down in your textbook. Now, letter G is a little challenging, so let's take a look at this. This is just going to be 1 over 2, or 1/2. This is going to be plus 1 over 3 to the 2nd, which will be 9. Now they're asking us to add these, so we need to have a common denominator, which is 18. Want to add fractions. Again, I want to multiply each of these by 1 so that our denominators become 18, and then the equivalent fraction. So for this one, I'm going to multiply it by 1 in the form of 9 over 9. So this becomes 9 over 18, which is 1/2. And I'm going to multiply this one by 2 over 2 as my form of 1. And this becomes 2 over 18. Now I have common denominators, so I get 11 over 18 is my final answer. Now for letter H, when I have a negative exponent in the denominator, all I need to do is bring it up to the numerator. And that's my answer. Again, crossing the division bar, you just change the sign of your exponent. So again, if you want something positive, this you're going to leave a 1 up in the numerator, move the negative 9 down, becomes a positive 9, so this will be x to the 11th. Here, to make this positive, you're going to move your negative up, and this will then become 5. The negative 3 becomes a positive 3, p to the 7th. Again, you want your answers to be positive, so there'll be a 1 left up in the numerator here. Bring the 3 down. That's going to be a positive 3, negative 1, positive 2, so 2 to the 2nd is 4. Here we're going to simplify. Let's clear that up too. We're going to simplify. This is going to be 1/5. Now our x's, we want positive, so there's a positive 1 down there, negative 7 up there. We bring it down, and that's going to become x to the 8th. We're going to move the y up. There's a positive 2 already. Add 5, y to the 7th. Now in a case like this, we wouldn't write the 1. So to have this look in a better form, we'll take the 1 away. Okay, now for something like this, I would suggest you simplify the top first. Remember, this is a grouping symbol. So we're going to get 3 x to the, adding these up, a negative 1 over x to the 6th. So this is going to end up being with a 3 on top. Our negative 1 we're going to bring down, and this will be x to the 7th. So here we did subtraction, essentially, got a negative 1, and then to keep our exponents positive, we bring that down. And there the work is on the next page. All right, example 7. Now here they want us to simplify along with keeping in mind that a and t are non-zero integers and that x is not a 0. Alright, so let's take a look and see what they are doing here. So in letter A, we have our bases, x, but our exponents are in this form. But what did we say the rule is? Well, the rule is we just add our exponents together. So that is our answer. Now, in letter B, we said we are going to subtract. That is, change the signs up here and then add them. So in letter B, we're going to do something similar. There's our example. Now we're going to take this up and just change their signs. So in the denominator, this is a positive t. So up here it'll become a negative t. This is a negative 5. Up here it will become a positive 5. And now we just add. So we get x. We're going to subtract a t from that and get a t. we're going to add 5 to a -1, and we get a +4. And there is our answer. Okay. Now our last topic in Section 1, our objective is to convert between scientific notation and standard notation. Well, here we're talking about very, very tiny things that have lots of decimal places and distances between Earth and Sun, which are really big numbers. So we want to develop a rule for that. And the rule is, take whatever number you have and make it a number between 1 and 10. And we see that right there. And then you're going to raise that number to some exponential power. Now, if it's a small number, those powers will be negative powers of 10. Large numbers, positive exponents of 10, powers of 10. So let's see it in action. Now, what I like to tell my students is, here's your number, 730,000. Now we're going to eventually put that as a number here between 1 and 10. We're going to times it by some power of 10 and then have it to some exponent. Big numbers will have positive exponents here. Small numbers will have negative exponents here. So we look at our number. This is in standard notation, and there's a decimal place right here. So we start off by moving the decimal place, keeping track of the number of places we move it until we make it a number between 1 and 10. So 1, 2, 3, 4, 5. I moved it 5 places. So I put the 5 right there. And the number I was left with between 1 and 10, 7.3. Now, I probably could use this to save a little room and time. I want to make this a number between 1 and 10, multiply it by some power of 10, and I want to remember how many decimal places I moved it. So, starting here, I'm going to count 1, 2, 3, 4, 5, 6. Now I moved it to the right and it's a small number, so this is going to be a -6. And the number I ended up with was 1.04. And that's what I have. And that's what I have. So you get a chance to do some as well. Now here is 7.7 times 10 to the 8th. And you want to put this in standard notation. Well, you look at the exponent. It's a positive 8. So you start at the decimal point of your scientific notation, a number between 1 and 10, and you're going to have to move that decimal place how many places? Well, you're going to move it 8. Now remember, there's 1 there, so you're going to have to add 7 zeros so that eventually you move it over 8 places, and that is your answer. Now for this one, you have 1.025, and it's a small number, so you're going to have to add 3 decimal places. There's 1. but you're going to make it a small number, so you're going to add zeros on this end, or decimal places. So how many decimal places do you need to move this? And the answer is 3. Well, there's 1 there, so you need to add a 0 and another 0. So there's the 3 places that eventually you're going to move it. And we put our decimal place there, and we usually add another 0 to fix the decimal place. So that is the answer, and that is the technique. And you'll have time to practice as we move on to our mini lecture. And of course, there's the exercise set.